Good afternoon. This is Ralph Brandt from the Fireside. One of my friends on YouTube that does a tremendous job is a guy who does what's going on with shipping, and it is a great site to learn from. When he says Bab el Mandab, which is the name of a strait between the Red Sea and the Strait of Aqaba, he always takes a drink. So, in honor of Sal, I just had a drink. Now that was water, and I'm reasonably sure Sal's is water too, even though he is an ex-sailor. And of course, I'm sure we've all heard the jokes about a drunken sailor. Well, let's get into what we're really going to talk about. We're going to talk about a super heterodyne receiver. And in particular, the one I'm going to talk about today is one of roughly 3 basic models of the 5-tube version that were built in the 40s and early 50s. The earlier ones used the octal tubes. A few of the Philcos used loctals. By the way, a loctal is an 8-pin tube, but the pin and the center pin arrangement is much different. It's the same size, but the pins are tinier, and when you put the tube in, it locks in place. That's why the term loctal. And to get it out, you have to tilt it a certain way. I've talked about that in another video a little more. The basic structure of the AC/DC super heterodyne, and by the way, it was AC/DC. It would run off of DC, and oh, by the way, up until not a few years ago, there was still some DC in places. The neat thing about this is if you plugged it in the right way, the DC would go through the rectifier and the radio would work. And that had to be 110 roughly volts DC. The basic super heterodyne had 3 12-volt tubes, a 60-volt tube, and a 35-volt tube. And if you add those together, they come up with about 120. If you put the filaments in series, and by the way, all of them had the same current drain. So in series, they matched. And as a result, they didn't need a power transformer for the filaments. Earlier versions, and good radios even at the time, used a power transformer to get usually 6.3 volts. Occasionally would be something else. If it was something else, it was usually 12.6. Yeah. The basic tube lineup in this was a pentagrid converter on the front end, 1 IF amplifier, a diode detector and audio amplifier in 1 tube, and a power amplifier. I'm going to talk down through each one. Oh, by the way, I forgot the rectifier. That took the AC and made DC out of it. Let's start at the front end. On the front end, we have this thing called L, which is really a coil that served also as the antenna. And it was paralleled with 2 capacitors. One of those capacitors was ganged with another capacitor that would maintain the tuning of the oscillator and the front end, so that you were tuning the grid of the pentagrid converter that had the signal coming in, and you were tuning a local oscillator to a frequency that was 465 kilohertz from the signal frequency. And these had to track over the broadcast band. When you were at 600 kilohertz, the oscillator would have to be at 1065. When you were at 1000, it had to be 1465, and so on. It had to stay exactly 465 kilohertz off. Now, I take that back because there were ones that the IF ran at 455, some of them 465, and some of them at 456. I do not know why those three were chosen, but they were. Some of the earlier super heterodynes, and not in this class, used 171 kilohertz. Again, it's heterodyning, where when you mix two frequencies, you get out of that circuit the sum, the difference, and the two frequencies. Now, when you come out of that circuit, you come into a tuned circuit, and that tuned circuit is tuned at the IF frequency. In the case of the radio I'm looking at, it's 455 kilohertz. And by the way, the documentation says kilocycles, because that was what the unit was called in the 1940s. Okay, this first thing that looks kind of like a patchwork is really an inductor, and it also served as the antenna. Across it is, of course, one of the two ganged capacitors and another capacitor. That capacitor was a trimmer that could be adjusted with a screwdriver to bring the frequencies on. Now, if you look below the tube, there's another pair of coils, and those are the coils that feed the local oscillator into the mixer through the cathode, not through a grid, but through the cathode. The other side of that coil is the tune circuit that tunes the oscillator. And the oscillator uses the first grid. This tube has two functions. One is to bring in the signal and amplify it and mix it. The other is to create the local oscillator frequency. By the way, one of the interesting things about this is that if you had sensitive equipment and were near one of these radios that was working, you could find the local oscillator and thus tell what station the person was listening to. There's a couple of other things in that mixer circuit, but the biggest thing is the plate goes out to another tune circuit. And that tune circuit is tuned at 455 in this case. And it's a transformer. And the other side of that transformer is another tune circuit. And what we've just done is created two tune circuits that are going to limit the size of the passband, what signal goes through. Now, this is pretty broad, and separating two stations is not good at this point. However, it goes into an IF amplifier, and that's just a simple amplifier with a grid, cathode, and when you come out of the other side, it goes into another IF transformer that, again, has two tune circuits in it linked together. By the time you get here to the output of that second coil, you've got a pretty compact passband. It's probably 20 kilohertz wide, which means that a strong signal sitting on one side or the other, if you've got a weak signal, you're not going to be able to push out block out the strong signal. But it was good enough for most places. Most places you had a local station that was relatively strong, and all of the other stations were weak. That output of that transformer T3 goes to not a grid, but a diode. And that tube has two diodes. Those two diodes work together to produce audio. And that audio is fed into the grid of that tube across C11 through a variable resistor. That variable resistor is the volume control on the radio, and it's fed into the grid. The reason for it being fed with that capacitor is to prevent the DC bias from that going into the grid. The grid is actually DC biased through another resistor called R7. Now, if you look at the other side of this variable resistor, it goes to another resistor and another resistor, and that backs off to a circuit that feeds two grids, one on the IF amplifier and one on the pentagrid converter. That bias voltage is generated by how strong the audio signal is. And what it does is it biases these two tubes to have less amplification if it's strong. It's referred to as an AGC or an AVC, automatic gain control or automatic volume control. These receivers, you could tune from a weak signal to a strong one and not have to adjust the volume because of that circuit. Now, let's go to the next stage. We have an audio amplifier. It comes off the plate of the 12SQ7, and it goes into a capacitor. Now, that plate is fed through a resistor, and we'll talk about where it comes from in a minute. But there's a capacitor going into the grid of the power amplifier. That is the output which feeds the transformer that feeds the speaker. The reason for that capacitor is that the plate of the first audio amplifier, the triode, is at probably 150 volts. If that were fed into the grid of the power amplifier, it would destroy that tube. The capacitor blocks the DC, but it allows the AC to go through, and that capacitor is like a 0.002, which at audio frequencies provides very little reactance. Now you hit the power amplifier, and that power amplifier is beam pentode rather. It basically provides some pretty good beef out on that output. You have a transformer because the output of that tube has an impedance of a couple thousand ohms. Speaker is 8 ohms usually, and we've got to have a transformer to step that down. By the way, the turns ratio on a transformer for voltage is the relationship between the voltages. Twice as many turns, twice as much voltage. On the impedance, it's a square law. Twice as many turns, 4 times the impedance. And of course, if you look at the speaker, it's a permanent magnet. Now, let's go back and look. Down below, we have the AC line coming in, and it goes through the filament on the 35W4, and we'll talk about the tube types. Back through the 50 volt tube, back through the 212s, and to the switch, okay, which interestingly is in the cold side of the line. We also have a capacitor here to smooth that DC. Remember, the plus DC comes off of the cathode of the tube. I'll talk a little bit about something else here. If you look at this, you'll see that the pentagrid converter has a blue tag of 12SA7, and if you look carefully, it has another number, 12BE6. This diagram was the diagram of the tubes that were of the 12SA7, 12SK7, 12SQ7, 50L6, and 35Z5 tubes that were octals. This same diagram was used with a 12BE6, a 12BA6, a 12AV6, a 50C5, and a 35W4, which were miniature tubes, the little 7-pin with the small pins on the bottom. But the circuit diagram was identical. I will say this, a couple of the components may be different, and from one radio to another you'll see a few changes, but basically those radios from the early 1940s versions until the 1950s when they quit making them did not change. Actually, they probably didn't quit making them into the late 60s. They just weren't many of them. Remember that transistors started coming in the mid 60s and were a lot more convenient. But this is the super heterodyne receiver. It is called super heterodyne because you're heterodyning two signals in the converter and make an oscillator that's together and amplifying only one frequency. This allows you to have a very tight control of the frequency and a tight control of the selectivity. And then we have, of course, the detector, the audio amplifier, the feedback of the AGC, and then the power amplifier. A very simple circuit, and one that there were tens of thousands of these radios built. There were a lot of them built during the war. I didn't mention down at the bottom the panel lamp. The 47 is a regular lamp, and it had to be ballasted, otherwise it would have burned out. And it was ballasted by putting it out of the 35Z5. And by the way, if you look at a 5 or 6 transistor radio from the same era, you would find only the big difference that the pentagrid converter would be 2 transistors, one an oscillator, the other one the input mixer, IF amplifier, or sometimes 2, diode for a detector, another transistor for the first audio amplifier, and sometimes 1 or 2 transistors for the power amp. Occasionally it would be a pair of transistors in a push-pull configuration. Gave a better tone quality as well. I'm going to do a video on the 6-tube a little bit later. Thank you for watching. This is Ralph Brandt from the Fireside.